All right, so if you're watching this from home, this is what we're going through in class today. Hopefully you watched the videos from yesterday, so you understand the electron configuration. We're going to go into a little bit more detail today, and then you're going to do an activity. It's actually considered a dry lab, so not using chemicals. I will post the sheets for this, so if you're at home, you will need, mirror image. So this sheet will be posted, and then there's a bubble sheet for you to write on that will also be posted. So you can print that as you need, or fill it out online or with using Cami or whatever you need to do. All right, so the video yesterday went through orbital notation, and hopefully that kind of made sense to you. It did mention the shortcut version, which we're not going to use the shortcut version for this activity. So just remember, so for example, let me just draw these out really quickly. We have our S block, our P block, D block, and F block. So we have our, and this should be labeled on your periodic table. We did this in class. So then when we write orbital notation, then we start always with this 1s. So remember, this is 1, 2, 3, 4, 5, 6, 7. We start with the 1s orbital always. So if I'm doing something like nitrogen, I start with, these orbitals have to fill in order, the lowest energy one first. We always start with, over here, we go 1s. So if I'm looking at nitrogen, 1s2, 2s2. Then I go across 2p, so this is my 2p, 3, 4, 5, 6, 2p, 1, 2, 3. If I add these up, the 3 plus 2 is 5, 6, 7, it should equal the number of electrons that we find in nitrogen. Since nitrogen is element number 7, it has 7 protons, 7 electrons, so I know that I got them all. There's another way to express these. Remember when I said the p sublevel, the p orbitals look like this, and I said they're on the plane, so one plane goes this way, one plane goes this way, and one of them goes, this forward and back on that plane. And each of these orbitals in the 2p sublevel can only hold 2 electrons. So here's 1, and here's 2 that are in this, and we might call this the 2p x orbital, okay? And then I have, I'm going to change colors. Maybe I have another 1 electron here. Sorry, writing with my mouse, it's bad. 1 electron here. Maybe this is the 2p y orbital. And then maybe this one, oopsie, right here. So here's an electron in this 2p sublevel. This is the Z. Oh, just kidding, wrong one. So that would be the 2p Z orbital. Each orbital can only hold 2 electrons. So when we get to this 2p sublevel, this is a 2p sublevel. This is 3 orbitals that this gets broken down into. So another way to write this sublevel for nitrogen would be like this. So we're still talking about nitrogen. We might say in the 1s orbital there are 2 electrons. One is spinning this way, the other is spinning that way. Okay? Then the 2s orbital, one is spinning, we say clockwise, and the other is spinning counterclockwise, and we represent those with arrows pointing in opposite directions. When we get to the 2p sublevel, we have to break this down. 2px, 2py, 2pz. I must put one electron in each of these orbitals before I put a second electron in any of them. So 1, 2, 3, and I know I'm writing on top of things, so it's a little bit messy. And I only have 3 electrons, so I stop here. And again, it should add up to 7. So 2, 4, 5, 6, 7. This obviously gets a little more complicated when we move into, oops, sorry, trying to erase this. Okay, so things get a little more complicated when we move into this D block. I have to remember my D block starts with 3D. And you can label this on your periodic table. Like, in fact, that's totally fine to do that. Not cheating at all. I think we labeled the blocks, but we might not have labeled all the numbers, but this is important. So if I did iron, again, so on the video it talked about the shortcut way, but we're not going to use that for this. I want you to get used to doing it the long way. Then we can use the shortcut way. So let's start with iron. We go 1s2, then we move to 2s2, moving straight across to 2p6, 3s2, 3p, p orbitals hold 6, it's filled with 6. We move back over to 4s2, and then we actually move down a level to 3d, so we go from 4s, 3d, and then I just count. 1, 2, 3, 4, 5, 6. 3d6. So if I want to break these down into the separate orbitals, I'm going to pick a different color. You notice I don't put the little 2 subscript here anymore. I don't have to. In the 1s orbital, there's 1, 2 electrons, each spinning in an opposite direction. 2s. Now I have to split apart my 2p sublevel into 2px, 2py, 2pz, and I have to have 1 electron in each of these orbitals before I can put a second one in any. So 1, 2, 3, 4, 5, 6. That's the order we want to fill them. Then I go from 2p to 3s. 1, 2, and then I'm back at 3px, 3py, 3pz. I know this is really long. I have 1, 2, 3, 4, 5, 6. Now I'm in my 4s. When I go to the 3D, there's 10, right? There's 10 electrons in a 3D sublevel. So how many orbitals do I need to break that into? 5, right? So 1, 2, 3, 4, 5. So it's 3D. We don't try to write the planes because it just gets too complicated. The P ones, it's really easy. It's X, Y, Z. It's a lot more complicated with the D. So I have 3D6. So I go 1, 2, 3, 4, 5. Now each of those has 1. Now I can go back and put a second one in the first 3D orbital. And so that's how we would write the orbital notation, electron configuration for iron. The only other thing I want to mention when you get down into, remember this F block, that these fit up into here. So if I were doing, let's say, tungsten, I'm going to go back and get rid of this. So if I'm doing tungsten, and I am going to do just the shortcut version for this one because I don't want to go through all of that with you again. So tungsten, the shortcut version is I can go back to the last naturally occurring noble gas, which is xenon. Oh, xenon. So it's xenon plus 6s2, and then my element 57 is actually, we consider this a placeholder, so we say 3, this is 4d, this is 5d, so 5d1. And then I have to go down and go 4f, because look at it, it's 57 and then 58 through 70, so it's 4f, 14, there's 14, and then I go back up to, I'm actually 5d, 1, 2, 3, 4. I'm just going to change this to a 4. And then, of course, my f orbital I would have to split into 7, or my 4f sublevel would split into 7 orbitals. So hopefully all that makes sense. Any quick questions? Anything that doesn't make sense? Hopefully as you work through this activity, as you help each other, that's why we work in a little bit larger group. So hopefully it makes sense.